Um, this is two motors I I use as a generator. This one serve as a motor. This one serve as a generator. So you can see how I designed it. So both of them are the same pole. This one is a 30 pole. This one is 30 pole. So the same pole, but slightly different capacity. Different capacity. So I designed it in a such a way that this one will be like a driver. This one will be like a motor. Why this one will serve as a generator? I see the output here. It serve as a generator. So okay. So now here, this is the BLDC model I will use to drive this generator. Here now, what I want to design is I will use a 12-volt motor. Drive this motor can go for 36 volt. So this motor can handle up to 50-volt input. Can handle up to 50-volt input. So from 12 volt to 60, I think 50 something volt maximum. So that will determine the speed. The more the input, the more the power, and the more the speed from this motor. So, but I would just want to use 12 volt to drive it. And how the design I want to, how I intend to do it is that I want, if this motor drive this, if this battery drive this motor and it drive this generator, then from the input I will feed it back in this battery. But I encounter some challenges. I encounter some challenges, which is the drag effect. So let me connect so that you see what I'm talking about. Okay, so let me connect. This is the men's yellow, green, blue. So let me connect it according to the color code. So the yellow wire goes for yellow machine. Then blue wire goes to the green wire. So the green wire. Okay. So it tallies with the color code. So you have to make sure that it tallies. So yeah, now this is the Hall sensor wire. So you have to go inside so that it will determine the position of the magnet. So now this is the positive. The yellow wire, I use it as a positive. So now let me connect it to the motor. Let me connect it to the motor. Okay, so now see. So when I put, it will start rolling. That's it. Okay. So here is the input potentiometer. If you want to decrease the speed or increase it, but I just leave it in the. I just leave it at this pin. So now, uh, this is a 60 watts 12-volt bulb. 60 watts. So you can see where there it is here. That's it. 12 volts. 60 watts. So it is a DC, but the output of this thing is AC. But due to it is a it it is not electronics, it is a direct, it won't affect it much yet. So let me determine the speed, the voltage per single phase of the output. I'm supposed to use a three diode to convert the three phase to single phase, but let me just uh, test it like that. So each single phase. So so now let me connect it. Okay. So now let me do the connection. You know, 16 volts. Okay. 18.2 volts. A single phase. 18.2 volts. So remember, I'm using 12 volts to drive it. So with the 12 volts, I got up to 18 volts. So I got high voltage. So now uh let me off my meter. So let me connect this 12 volt 60 watt bulb, origin bulb. So let's see what will happen. Let's experience. Remember, you see the motor is running smoothly. Everything is running smoothly. See. So now let me connect the bulb now, so that we see what happens. Okay, I've already connected the bulb, so you can watch. Very very bright, but you can see the motor is struggling to rotate the this motor. This motor is trying to rotate the generator. There's a physical struggle without much. Okay. So now let me uh let me check the amp. Let me check the amp. Let me this my meter to check the amp. So now I will connect the one of the terminal, one of the terminal of the battery. I mean the this thing to the meter. So easy to determine. So one of the terminal. So remember. So let me disconnect the load first. Let me disconnect the load first. Okay. So now let me wash. Okay. Not much amp. Let me reverse the connection. Let me reverse the connection. Almost the same thing. So there's no much huge amount of current draw from the let me connect it from the positive reading. Let me connect it from the positive reading. Okay. So now let me yeah. Okay. So now from the positive reading, almost the same thing. There's no uh, uh, much current draw from the motor. The motor is efficient, but the only thing is speed. It doesn't have much speed, but it has more torque. So you can see just rolling the motor with the generator without any load input. No much current draw. Oh, sorry. Yeah. Oh, sorry. I put the amp reading. I put the amp reading on AC. So let me shift it on DC. the white reading, the white paint is from DC, so I put it on DC. Made a mistake. So let's check. Hmm. So almost barely 1 amp, barely 1 amp. So before we are reading it on AC. So barely 1 amp. Let me use my hand as a load. So let's see what is happening. Let me use my hand as a load. Okay, you can see. So barely 1 amp, barely 1 amp. Okay, now um, I'm gonna connect load. You know, this is a digital meter, so it's not supposed to read the current too so long. Because you can see 10 seconds maximum. So you should not put it at long to avoid damaging the meter. Assuming it is a clamp meter, we can leave it for long. So now remember it's take almost barely 1 amp to rotate the motor. So now let me connect this load so that you see the increase and the surge increase in amp. Let me connect it. Okay, I've already connected the 60 watts bulb. So now let me run the motor to see the how many amp it will draw. So 6 amp, 6 amp. So additional of 5 amp, additional of 5 amp. Okay. Even rotating the motor is not seem to be hard because of the load. It's not rotating freely again because of the load. Oh, let me disconnect it again. I see. You see the difference? Barely 1 amp, and it rotated freely. So, so um, what I found out about the issue is my experience. Like what I discover with the system is, you know, like I said, this motor is a 30 pole when you count it. So this is the lotto. This is the lotto. This is the lotto here. So when you let's start from here. Okay, let's start from here. So, so let's start from here. Let's mark it. We are starting from here. Okay, now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, 27 pole. There are some of 30 pole, but this one is 27. So this lotto here is 27. This one is 27. So two of them is 27, 27. Two of them is 27. So and this one is slightly more powerful than this. So what I found out is that both of them have the same torque. Like this one is more stronger than this torque. So to eliminate uh, uh, the uh, the torque, we have to use something about 12 uh, 12 pole instead of 27 pole. The same with this driver, the motor I use as a driver, this motor now. I use this one as a generator. So both of them have the same pole. So for us to drive it so that the torque of this one can surpass the torque of this motor is, we have to go for generator that has lesser pole, because the more the pole, the more the cogging. In generator, the more the pole, the higher the cogging. In a motor, the more the pole, the higher the torque. So it's a pari passu. In a generator, the more the pole, the higher the cogging, and the lower the voltage it will generate. In a small RPM, it will generate a lot of voltage. But in a motor, the more the pole, the higher the torque, the lower the speed. Because 12-volt motor, when you put a 12-volt input, it will drive thousands of RPM, 3,000, 2,000 RPM. But this one, I don't think it reach. Let me check the RPM. Let me check the RPM. Let me. Tachometer. Let me. Okay. Let me check it. Let me disconnect it from the motor, from the meter. Okay. 200. 224. Okay. Let's say 200 and. Okay, about 224 RPM. 224 RPM. But if it is a 12-volt motor, it will run thousands of RPM. So this has some kind of torque. It has a torque. So I can't stop it with my hands. And the second phrase is much, but I can't stop it with my hand. So when I try to apply it, I can't stop it with my hand. So like what I'm trying to say here is maybe you can see this is the conventional generator we are using. It is a two pole. You can call it single pole, you can, because it is only one north and one south. So this is the conventional generator we are using. You can see here is the north, here is the south. So it has only one north, one south. So, but this one, it has a 27 pole, which means north, south, north, south, north, south, north, south, north, south, north, south. So that's how it goes. North, south. So when you count how many north that is there, it's more than 10. And when you count how many south that is the pole here, it's more than 10. So, but this one is only single north, single south. Like in the armature, that's how it goes. Either this is north and this is south, or this is south, this is north. So with it, this such generator, it only needs speed, but it doesn't have much torque like this one. So this one can drive this generator efficiently, but the only problem is the speed, because this such coil need about uh, 3000 or 3500 RPM to generate 220 volts, depending on your winding and turns. You can see. So, but when it comes to torque, this motor can drive this generator efficiently because the torque, it has a enough torque to drive it. But the only issue is this motor doesn't have much speed to generate, to induce, for this armature to induce current in the starter. I don't know if you understand. So that is what I just found out. So this motor are the same pole. I mean the same number of pole. So they will be encountering each other. They will be encountering each other. That's why that we use 12 volts to generate about 18 plus, 18 volt plus. We use 12 volts to generate 18 plus. We have a gain in voltage. We have gain in voltage, but due to the torque, so it suppress all those voltage down, and you can see the current rise from 1 amp, barely 0.90 amp to about 6 amp. So additional of about 5 plus the additional. So that is what I just discovered about this sort of. So this sort of, even if we want to we drive it, we have to use lesser pole, maybe something about 6 pole, 8 pole, 10 pole, 12 pole, so that this motor can have upper hand on it. So, but both of them are the same pole. So that's why this motor struggled to rotate the generator when I put this 60 watt 12 volt bulb. That's why the motor struggle to rotate it. So, and it take a huge amount of current from the input. So, and all those things contributed what they call back EMF or lens effect. So, because assuming it is not present here now, I can drive this generator successful, maybe barely 2 amp, and I will generate 60 watts. I put 60 watt bulb. So because the higher the pole, the higher the current in the generator. In the motor, the higher the pole, the lower the speed and the higher the torque. So it works vice versa. I apply current here, it drive, then I draw current here. I apply current. This generator I draw current. So what I found out is that using uh, the same pole, the same pole to drive each other, we have some bigger disadvantages. So either we use a 4 pole to drive 2 pole, or we use 6 pole to drive 4 pole. So we have to use higher pole so that it will have some higher torque. Because what a torque does is that when you put load, it will keep running. But when it have an insufficient torque, when you put load, it will stop immediately, automatically. So that's what I just found out about the system. Though it perform better, but this is what I just discovered. It has a high cogging. So I want to use it and feed it back to this battery. So it works, but it has a high cogging effect due to the both of them are the same pole, the same 27 pole. So that's what I just discovered. So for it to work, we have to use a lesser pole, maybe something about 10 or 6 pole. So that's what I just discovered. But if you have a suggestion, likely to hear from you. Thank you.